Great. Thank you very much, Paulo, and thank you everyone for coming. I'm going to sort of give a brief overview of some research in what's being called network epistemology. Obviously, I'm going to just scratch the surface of a few things. So if you have any questions about additional research or about anything, I'm happy to point you in the direction. I've included some citations on a variety of the slides for those who are interested in learning more. So I wanted to start just briefly by kind of reminding everyone of what we might think of as the kind of origins of traditional epistemology that, in many ways, Descartes, I think, represents a kind of beginning point for the way that we think about epistemic problems, even well into today, although obviously there have been changes. And I think it's also a useful foil to think about Descartes, because Descartes had a very individualistic idea of epistemology. It was really critical to him that good epistemic work, that is good reasoning, was built entirely on one's own thought, that relying on other people was sort of anathema to him, that one shouldn't do it, and that in fact one, in the method, he's quite clear that one should sort of throw away everything that one learned from everyone else and start afresh. As time goes on, of course, people and as science develops, it becomes obvious that this is not really tenable, that one can't totally create everything afresh to oneself. And so, by the 18th century, you get people like David Hume and Thomas Reid, who recognize that, in terms of epistemology, we do occasionally have to rely on other people. And so we need to think about how it is that we can learn from others. That shift sort of carried with it into the 20th century for philosophers who began to start thinking about what is now called social epistemology, the idea of thinking about the social nature of knowledge. But even as this social shift took place in philosophy, it still nonetheless retained a kind of individualistic focus. So philosophers got interested in problems like testimony, that is, how can we learn from other people? Issues like peer disagreement, what do we do when we discover that we disagree with someone else who we regard as epistemically similar to us? Expertise, how do we figure out who it is we should trust and under what conditions we should trust them, etc. And although these are somewhat social shifts, they're still somewhat limited. That is, they still retain a kind of individualistic mindset that we inherited from Descartes and earlier. That is, it's still focused on what should I do? So unlike Descartes, I'm now willing to entertain the idea that I might learn information from others. But like Descartes, at the end of the day, epistemology is about what should I do, not about what we should do. So it's still nonetheless a very individualistic focus. And also, the focus on problems tends to be primarily a dyadic, pairwise, right? So what the model is, I am interacting with one other person, learning about their testimony, discovering that they disagree, or determining whether or not they're an expert. And so the social interactions that we're interested in, social networks really have no place there, because there are only two types of networks when you have two people. There's either a connection or not, basically. And so as a result, even into today, a lot of epistemology, even what gets called social epistemology, is nonetheless somewhat limited and still somewhat focused on what I think of as still a somewhat individualistic mindset. Of course, not everyone is doing that, and I don't mean to suggest this as a criticism of the whole field or something like that, but just as a kind of thrust that you'll still see in modern philosophy. There are a couple of threads that take bigger focus. The first one is focused on what I'm calling ontological questions. So here we've got people like Michael Bratman and Margaret Gilbert, who are focused on questions like, can groups have beliefs? What's the nature of justification for a group? Can groups have intentions? These sorts of things. I'm not so interested in that, and so I just mention it to sort of set it aside. It's an interesting set of questions, but just not what I'm going to be talking about today. Instead, what I'm going to be talking about is a different focus, which is looking at what sometimes gets called epistemic systems. This is a term that goes back to Alan Goldman. The idea is that you take an institution of some kind and you think about the epistemic features of that institution. So you might think of something like juries, or this structure of science, or educational institutions, or a company's R&D department, or who knows, But you take that as a unit of analysis. a group is a singular unit of analysis, and you ask about properties of that group and what make that group better and worse. You'll notice that this is already somewhat different, right? So the fundamental unit of analysis is a group. Of course, we can inquire inside of the group about its internal properties, but at the end of the day, we're principally interested in the properties of the group, not the properties of the individual. Secondly, it's focusing on them as an epistemic system collectively rather than individually. So we're not asking how should an individual behave within a group, or at least that's not our principal focus of analysis, but rather we're interested in questions about how should the group be constituted? That is, what do we make it different? So that, I think, represents a more radical departure from the original Cartesian model of epistemology to one where groups really come into focus, and we start asking about properties of those groups that go beyond dyadic interaction. So there are many different social systems, of course, that one might look at. Since our focus today is on networks, I'm going to focus on networks as an epistemic social system. So we can ask about properties of these networks that might make them better or worse. So here I have a picture of two different networks. There's nothing really that critical about them, but they differ in a lot of respects. So, one of them is smaller, has fewer people. One of them is larger, it has more. One of them has lots of connections. The other one has relatively few. One of them has a very symmetric, or what you might think of as flat, social structure, where everyone is very similar to one another. The other has a very hierarchical social structure, where some people are very central and very connected, while other people are very peripheral and not very connected, and on and on and on. Right? And so we can ask about these things, what makes epistemic networks better and worse, and for what purposes? And let me underline that last caveat there, because that will sort of be the broad conclusion that we come back to, which is that, things that you might think of as very intuitively obvious or straightforward questions don't really have a singular answer, but rather multiplicity of answers that depend on individual purposes. Before I jump into a couple of examples, let me just highlight that this is a very broad field, which involves a variety of different methods. So, these are sort of a rough categorization of methods. The first one is sort of, we might think of as empirical, measuring existing social networks and their epistemic properties. This a methodology is just, is right now is gangbusters, because all of a sudden we have access to relatively easy to acquire data sets. It used to be very hard, as I'm sure Professor Collins or Dr. Rossini can tell you. It's very difficult to figure out what the social network is prior to the invention of Twitter and Facebook. But these days, it takes a couple of days and a computer, and you can download this, not all of Twitter, but at least some subset of it. So as a result, there's an enormous amount of research going into understanding this empirical structure of the network and how ideas go across them, things like that. Very, very interesting book. Historical, this is, Professor Collins gave us a great example of this already, the reconstructing historical networks and looking at their behavior and looking at their structural properties. There's an experimental methodology where you actually take, oftentimes, real human beings, you put them in a laboratory setting into a kind of social network, and you see how they behave within that social network. This is pretty common in behavioral economics and social psychology. And then lastly, my preferred methodology for me is building mathematical and simulation models of the system. Now, just because I say that's my preferred methodology, I don't mean to suggest that I view that as the correct methodology and the others as the incorrect methodology. I don't think that there is any such thing. Instead, I think that these are mutually supportive methodologies. Each has virtues and vices, and each can sort of fill gaps that the other leaves. So I like computer simulation methodology because that's what I like doing, and that's what I find that I'm good at. But it's not as though I think that the other methods are wrong. And in fact, I think they're quite interesting. And in particular, finding synergistic conclusions, that is, places where you find similarities between them, it can be actually quite enlightening. I want to focus on kind of two themes, two ideas, and present you two examples that kind of show you how our intuitive judgments might be wrong about a couple of things. So the first is, I want to present you two theses, which are the kinds of things that I think that people, without too much reflection, would just endorse. That is, the first is, it's sort of always better to have more reliable information rather than less, right? Of course, we might want to limit misinformation or information in bad faith or something like that. But, so long as the information is reliable, at least on average, it's always better to have more rather than less. So I'm calling that the value of information thesis. The second one is what I'm calling the scaling up thesis. That is, if individuals do epistemically better, so if we make people smarter, if we make people epistemically more virtuous, or in whatever way you want to cash that out, the group does epistemically better. So the idea is that sort of epistemic goodness or epistemic virtue scales up from the individual to the group. And I want to present you with two examples where that does not hold true. I don't mean to say that these are everywhere false. They aren't. In fact, it's quite easy to come up with examples where these are true as well. But this is just to show you the complexity that arises out of the study of social networks. So the first example is actually originally comes from economics, but has been studied by a variety of different fields, including psychology and philosophy, and is a nice example that shows the problems with these two theses. So let me take a quick detour and just remind people who've probably heard at least one way or another this wisdom of the crowd thesis. And this is based on a very old idea due to Condorcet, and in fact has a few things that might be older than that suggests that groups of people can be better than their individual members. So we might imagine that if you have a bunch of people, there's some fact that they're trying to figure out whether it's true or false. If they independently come up with some judgment about its truth or falsity, so long as the people are, on average, more reliable than chance, then as a collective, they'll do better than any one of their individuals. So here, we might imagine that the proposition under discussion is false. Some people, of course, incorrectly believe that it's true, but the group as a whole, if it were to vote independently, would end up coming to the correct conclusion that the proposition is false. So this is a simple illustration. And it's a sort of natural idea that you might imagine, yeah, of course, it makes sense that so long as they're independent and they're not being influenced badly, so long as each of them is sort of better than chance, then more will be better. However, that independence assumption, which sometimes gets swept under the rug a little bit, is quite critical. And this is information cascades is one way to illustrate it. There are lots of ways to illustrate it, but this is one way. So in the information cascades model, we still have the same basic idea that there's some truth of the matter, say here that the proposition is false, and that each individual sort of forms an independent belief, except the difference here is that now the individuals end up lined up and they vote in sequence rather than all at once. It seems like a relatively trivial difference. So what does it make a difference if you're doing secret ballot voting, or if you're doing roll call voting where we stand in line and we each vote? But actually it turns out to make a huge difference. And that's because errors can cascade. And that's where the name comes from. So here our first person is in error. The proposition is in fact false, but she mistakenly believes it's true. So she announces that it's true. And we'll imagine the second person is also in error. So she also thinks the proposition is true. So we have two errors, but in a large group, that would be no surprise. The critical thing is now imagine our third person. So now our third person will imagine that she privately thought that the proposition was false. She said, I think it doesn't seem true to me. But now she observes that two people that to her seem just as smart as she is, have announced the opposite of her. Okay? And so now her judgment is, well, there are two people, they're both equally as smart as me. They both say the proposition is true, and I think the proposition is false. I must be in error. And so one can work this out in full mathematical detail, and absolutely correct reasoning on her part is that she should conclude that her initial judgment was a mistake. And so instead, she will announce also that the proposition is true, despite her private judgment that it's false. And nothing special about her. The same reasoning will hold for the next person, and the next person, and the next person. And so even though this looks just like our example before, where in their private judgments, 4 people thought the proposition was false and 2 people thought the proposition was true, the group as a whole appears to unanimously announce that the proposition is true, when in fact it's false. So this is an example of an information cascade. Okay? So this is an example of how falsehoods, if initially influential, can end up cascading through the group and cause what would have been a wise group to be, in this case, unwise. So here this provides the first illustration of the problem here, which is that this group does better when they communicate less. Right? They would have been better to just not listen to each other and to announce their private judgments, but instead they listened to one another, and in doing so became worse. And we can show that this is a broad phenomenon, that the groups as a whole are made worse when they communicate in this particular setting. And indeed, it's also a problem with the scaling up thesis, which is that each person privately does epistemically better by communicating. So that is, each individual, if she was given the option, should I listen to the people in front of me or not listen to people in front of me? Epistemically, it's better for her to listen to the people in front of her. But that collective behavior ends up making the group as a whole worse. So making the individuals better actually makes the group worse. Each person that you make epistemically better results in a worse social setting. So this demonstrates the falsehood of both of those. As I said, this is an old idea. It goes back at least to the early 90s with sort of two dueling, simultaneously published papers in economics, one by Banerjee and the other by Burchandani, Hirschleifer, and Welsh. There have been the most general economic treatment is this paper I put up here by Smith and Sorensen. I think it's still regarded as the kind of big magnum opus paper about these kinds of problems. For those of you that are interested in logic, there's a logical approach to these by Baltag, so Christoph, Jens Ulrich Hansen, and Sonja Smets in this 2013 paper. And there are lots of philosophers working on these problems as well. In fact, the logicians can be called philosophers, I think. Let me move on now to a second example. So this is an example that's largely due to me that Paolo mentioned in his introduction. So the value of transient cognitive diversity. So here we're imagining a slightly different problem. So in the first, we imagine that each person sort of privately forms a judgment, and then that's it. That's, all the information that there was to have is in their private initial judgments. Here we're imagining a more dynamic process, a process of research where we have to make decisions. So as an analogy, we might imagine a single scientist. Here she is. You can tell she's a scientist because she's wearing glasses. And she's confronting two potential research methods, the red microscope and the blue microscope. It's just sort of a caricature, of course, but we can talk about the details in a little bit more in questions if you like. She has to decide which method is better. And she doesn't know ahead of time. The only way for her to figure this out is to try out the method. So imagine she starts by trying the red method, and it turns out, okay, it's good. It produces 6 truths or truths to value 6 or something. It's not really critical that we think about these numbers too much. Just as a kind of simple example, we might think this is a pretty good method. It's produced some high value. But of course, she doesn't know, is that good or bad? How's the other method doing? She doesn't really know, so she has to try out the other method. So now she tries out the blue method. Oh, it looks like the blue method does slightly better, produces slightly more interesting or slightly more reliable results, something like that. Okay, so seems good. She sticks with that. She tries it again. Now it totally fails. So now she gets something of no value whatsoever. So now if you think, well, on average, the red method seems to be doing better than the blue one, so let's try out the red one. It doesn't do so well either. So now on average, they're doing about the same. Maybe she goes back to the blue method. Oh, it's done okay. And so maybe she sticks with that one for a while. Right? So this is the underlying learning problem model. She's making dynamic choices. And she has to both make choices, but also learn from those choices. This model is sometimes called the bandit problem model. It's an old statistical problem, which goes back at least to the 1940s and 50s. And it's a way of encoding what we think of as a kind of fundamental tension that happens in science, but also a lot of other disciplines about the balance between what's sometimes called exploration and exploitation. That is, on the one hand, we need to try out new things and new ideas and new ways of approaching problems. That's the exploration side. But on the other hand, also, we can't spend our whole time coming up with new methods. Sometimes we need to take the methods that work and apply them, right? I can't just sit around trying to come up with new ways of studying networks. At some point, I need to use the best way that we have and study some actual networks. And so that's the balance between exploration and exploitation. We might take this model and apply it in a social setting where now we have a bunch of people who are interacting with one another, who are each trying out the different methods, and they get to learn from each other. So they try out a method, they see how it does for themselves, but they also see how other people do. So I get to see how someone else does. And we can ask, what's the best social network for them to be in? Here I've just looked at 2 extremes for the purposes of this quick talk, but if you want, there's lots more details. Here the 2 extremes are a very, very simple social network. That's one is called the ring on the left-hand side. That's where each person is sort of arranged in a circle and they can see the 2 people on either side of them, but that's it. So very informationally limited. The other one is the complete network. Everyone can see everyone. It's almost not a social network. It's just a community where everyone communicates with everyone. And it turns out that in this setting, the less connected network does better. So here I've plotted the results of some computer simulations. On the x-axis are the number of players, the size of the community. On the y-axis is how well they're doing. Higher numbers are better. The blue circles represent how the cycle, that is the ring, is doing, the people who are connected to the left and right. And the pink squares represent how the complete network is doing. So we see as the network gets bigger, it turns out that less communication is better. And this is something that I detail in a couple of different publications, including this 2010. Why is that? Well, there's a bit of a long story here, but let me give you the one sentence explanation. In the complete network, everyone gets access to all the information. And so as a result, if the information happens to be misleading, it can't be misleading on average, but it just accidentally is misleading, it causes everyone to abandon one method in favor of the apparently superior one. And sometimes they're wrong. Whereas in the ring network, it maintains diversity for longer. It keeps people trying out different options. Bad information is contained. So too is good information, it turns out. But by bad information being contained, it ensures that the community is diverse and maintains its diversity longer in a way that is ultimately beneficial to the community. It's important to say that there are a few caveats. The problem must be hard. If the problem is too easy, then that balance between containing bad information but also containing good information shifts, and then it goes in the other direction. And agents have to be somewhat limited in their foresight. And I can talk more about that if people are interested in details. So the conclusions from this example also represent a contradiction of those two theses that I started with. That is, groups don't do better when they communicate more. They do better when they communicate less. So the value of information thesis is wrong. And the scaling up thesis is similarly wrong. Each person privately does better if they communicate more. Each person would privately do epistemically better if they themselves could communicate with more people. But making each person do epistemically better for themselves makes the community worse as a whole. Again, let me give you just a quick summary. So many of the details of this were originally published by me in 2010, although I was drawing on some work by some economists. This is the fourth one, Bala and Goyal, in 1998. So it wasn't entirely original to me, although I did some things that they didn't. It's been explored more recently in this paper by Sarita Rosenstock and colleagues, looking at the limitations of some of my early analysis. And then this kind of model has been applied to a bunch of different problems. So, for example, Jim Weatherall, Kaylin O'Connor, and Justin Brunner have looked at it in the context of propaganda. And Bennett Holman and Justin Brunner have also looked at it in the context of industrial funding of science. So if you're interested in these kinds of topics, I'd encourage you to take a look at some of these others. Okay, so broad conclusions. Sorry, I've gone a little bit longer than I had initially hoped. Networks provide a good opportunity to consider large-scale epistemic systems. They're not the only thing of interest in large-scale epistemic systems, but they're one of the things that are of interest. Many of our intuitive epistemic principles fail in that context. So things like the value of information thesis or the scaling up thesis turn out to not be true everywhere. Now, I haven't given you examples of this, but it is actually relatively easy to produce examples where the value of information thesis is true and where the scaling up thesis is true. So it's not like I'm saying those things are false everywhere. Instead, what I'm saying is it turns out that things are complicated, that in some contexts, those theses are true, and in some contexts, those theses are false. And we can start to make some generalized conclusions about what makes them false and when they're going to be false and when they're going to be true. But we can't sort of give you simple answers to what's the best epistemic network. Rather, the answer is, it depends. It depends on the learning problem. It depends on features of the situation. It's not that we need to throw our hands up in despair. There are some generalized answers to be had, but they're not as simple as we might like them to be. And so as a result, for policymakers, maybe that's bad, but for us researchers, it's great. It turns out that this is a rich area that is worthy of our consideration. So thank you very much for your attention. I look forward to your questions, and I hope you're interested in this topic more.